right, episode 3, Bones. Today's episode is sponsored by Sesame Street. My boy Ernie's in the back.
Yeah, man, what's up?
What's up, what's up? So on today's agenda, we're going to be talking about the bones. Okay, what are they, their names, how do they work, anatomy, and physiology. Before then, Ernie wanted to drop some knowledge. Ernie, what is the meaning of life?
The sole purpose of human existence is to kindle a light of meaning in the darkness of mere being.
That's deep. That's deep. And what if I can't find the light? What if I can't find it?
Create your own light by adopting responsibility.
What a nerd. Alright, and now we'll be going over the spooky boy from the book of the world's best anatomical charts. So you know, I carry the best information. Yep. And now a little performance from Cardi B.
Somebody come get her, she's dancing like a stripper. Ay. Somebody come get her, she dancing like a stripper. Ay. Somebody come get her, she dancing like a stripper.
Alright, quick. So the skull, we have frontal part of the bone. We have the maxilla, which is above the teeth. Then we have the mandible, which is kind of like your jawbone. Then underneath that, we have the cervical vertebra. You have 7 of those. So you eat breakfast at 7. 12 thoracic vertebra. You eat lunch at 12. And then you have 5 lumbar. You eat dinner at 5. Simple, right? All right. Next, after that, we have the sternum. This is what they teach you in CPR. They teach you this bone, the sternum. And then we have a little xiphoid process, which I think means the tip of a sword. You avoid that. That's the bone you kind of crack during CPR if you're not careful. Then the next bone we have here is the clavicle. Where the clavicle meets the sternum is a sternoclavicular joint. Then here, the clavicle then meets the acromion. The acromion is part of... Get in my fast sausage fingers. Then we have here the scapula, right? The scapula is this Dorito-shaped thing. This Dorito has a bony prominence called the acromion. That acromion meets the clavicle, making the acromioclavicular joint. Okay, acromioclavicular joint, sternoclavicular joint. Then moving down, we have the humerus, right? Humor me here. Slap somebody's arm every time you say that. Humor me here. You'll be the coolest kid in class. Okay, humerus. Then you have your radial bone. The radial bone I memorized by looking at my arm. So your thumb is kind of like your antenna, right? Your radio antenna, your radial bone. Let me put the camera down. So this is your humerus, right? Humerus right here. Then you come down, meets the radius right here, your radial antenna. Cool thing about the antenna, about the radius, it's above the ulnar bone. So when you pronate your hand like this, the radius actually rotates. Okay, so if you see this is kind of like rotated here, then you kind of bring it into neutral, and then the two bones are in line. See, you can feel that in yourself. Cool, simple. Okay, so where the humerus meets the radius, it's going to be the humeral radial joint. Where the humerus meets the ulnar bone, it's the humeral ulnar joint. And where the radius meets the ulna, you guessed it, the radial ulnar joint. Coming down, you have the wrist, okay? This is where you find your carpal bones. You might have heard the term carpal tunnel, okay? You have where your hand hurts, okay? You have 8 carpals. I encourage you to Google the carpals and memorize those, or get a closer look at them. You don't have to memorize them. I don't know what you need. Okay, so where the radius meets the carpal bones, what do you think the joint is called? Radial carpal joint. Ulnar meets the carpals, ulnar carpal joint. Okay. Next, femur. Okay, femur. Then you have below that, you'll have a little bone here called the patella. Okay, the patella is a sesamoid bone. Okay, kind of like the sesame seed. It looks like this. It's covered by tendons and ligaments. Below that, you're gonna have your tibia and fibula, okay? And these two are connected by an interosseous membrane. So osseous means, or osseo means bone, inter means between, and membrane, You're crazy in the membrane. Interosseous membrane. Tibia is a big one. Fibula is a more skinny, smaller one. Okay, the foot is a whole different bag of burritos. I'll save that for a different video. Okay. I think we just went over the scapula. This is the scapula, and you have your ribs. Okay, 12 of them, but technically you only have 7 of them, and the other ones are connected to cartilages. That's about it. Iliac crest from your ilium. Okay, you have 2 iliums, and your sacrum. Okay, sacroiliac joint. These are all kind of like fused together bones where they meet from the L5. They come together. Then here you have your ischium, where your hammies originate from, your hamstrings. Okay, your acetabulum. What else? I think we'll leave that here. Okay, so again, quick. Skull, so you have your maxilla, mandible, you have your humerus, clavicle, sternum, your ribs, your radius, your ulna, femur, ilium, ischium, femur, tibia, fibula, patella, okay, yeah, scapula, sternum. Cool. That's it. All right. We just went over the anatomy of the bone structure. Now we're going to go over the physiology. Okay, so the physiology, let me get the technical terms in here. Physiology is the way in which a living organism or bodily part functions. Okay, and the anatomy is more so the bodily structure of an organism. Okay, so physiology number 1, that spooky boy inside you is actually alive. Okay, it's not just like a hard piece of metal that, you know, made of adamantium that just keeps you, you know, walking and lets your muscles move. It's more than that. Okay, it has feelings, it has nerves, it has blood supply. So when you break a bone, yeah, it hurts. When you have growing pains, yeah, it hurts. Okay, the blood supply. Step 2, so it does hematopoiesis or hemopoiesis. Hemo meaning blood, poiesis creation of. So it makes your blood. You know, that's pretty cool. Okay. So your red blood cells, they carry the oxygen. You breathe in, breathe out, and those little red boys get all happy and they carry around oxygen in your body. Then you have the white blood cells, which fight off invaders. Okay, when you have germs and such. You also have another thing called stem cells, which are made as well in your bone. And the bone marrow, that's the inside, the squishy part of the bone. It's squishy. The outside is harder. The cancellous bone, it's hard. Okay, compact, strong boy. Okay, stem cells are basically like soldiers with no training. Okay, they're blank slates. Stem cells are also being used in injuries now, sports injuries and stuff, like your knee is messed up, shoulders messed up. You inject some stem cells in there. Supposedly the research is saying that those stem cells then turn into whatever the body needs to recover. Okay, look into that stuff. It's pretty interesting. Okay, you have 2 different types of bone osteocytes, bone cells. Osteo meaning bone, cytes meaning cells. You have osteoblasts, which build the bone, and you have osteoclasts, which clash and destroy. They destroy the bone. So these 2 have to be in like a yin and a yang in harmony. If there's too many osteoblasts building, you get deformities like acromegaly, where you get prominences and like weird structures and stuff like that. And you have, if the osteoblast build, osteoclast destroy. If the osteoclast destroy too much, you get things like osteoporosis, where your osteo meaning bone, porosis meaning porous, holes, right? There's too many holes. It's no bueno. Okay, kids have growth plates, also known as epiphyseal plates. These are found on the end of long bones. So when we do modalities, which are like either physical agents or electrical agents that we use in physical therapy to help heal. Okay, so at the end of these long bones are kind of like cartilaginous when you're a kid. So if these things get injured, you won't grow properly. I was told that, you know, you'll have a longer arm or just shape different. You won't grow the same. So we have to be careful with these. Old people, they're made of adamantium, just straight iron. Okay, and these epiphysio plates close or get, stop. When you stop growing, when your growth spurt is done, that's when you don't have to worry about them. You can see them through an X-ray as well. You'll be able to see them if they're closed. Okay, and Wolff's law, very important in physical therapy. Wolff, as in wolf. Okay, what it basically states is that a bone will adapt to the stresses you place upon it. So the more weight bearing you get into the bone, the less porous it gets. It adapts to the stresses, and your like torsional stresses, which means like twisting and bending, and your bones do twist and bend. You have torsional injuries when you twist too much. Okay, so big ow. Okay, so like astronauts, when astronauts go to space, they don't get that weight bearing. Okay, so they start losing 1 to 2% of their bone density, so they have to start training up in space. So the more stress you place upon it, the stronger it gets. So, and when you do weightlifting, you don't just only strengthen your muscles, you strengthen the bones as well. And I think those are the key points to the physiology of bones. They're alive, they make blood, there's osteoblasts and clasts, one builds, one destroys. Kids have growth plates, also known as epiphysio plates, and Wolff's law. And if you stay physically active and you strengthen your muscles, your bones will get strong too. Okay, get your calcium, boy.